Normandy, France, July 1944. A Sherman tank grinds forward into what should have been open countryside and vanishes into a wall of green. Not a forest, not a hill, a hedge, 10 feet of ancient earth and root, packed tighter than concrete, rising on every side of every field like the walls of 1,000 tiny fortresses. The tank rears up, its belly exposed, its gun pointed uselessly at the sky. Somewhere in the bushes ahead, a German anti-tank gun crew adjusts their aim. They've been waiting for exactly this moment. In the next 10 seconds, that 30-ton machine and the men inside it will either survive by luck or die because of a landscape nobody back in London had ever bothered to study. This was the reality facing American armor after D-Day, and for weeks there seemed to be no way out of it. Then one sergeant, acting without permission, welded a piece of scrap iron to the front of a tank. His commanders could have court-martialed him for it. Instead, it may have saved the entire invasion. By the summer of 1944, the Allies had done the impossible. They had crossed the English Channel, stormed 5 beaches under fire, and cracked open Hitler's Atlantic Wall. But Normandy was about to teach them a brutal lesson. Winning the beach was not the same as winning the country behind it. Inland from Omaha and Utah lay the bocage, a patchwork of small farm fields that French peasants had been fencing off since the Middle Ages. Each field, sometimes no bigger than a football pitch, was boxed in by earthen banks, 3 to 5 feet high, topped with centuries of tangled hedge growth that could reach 10 or 12 feet into the air. To an American soldier raised on open highways and wide-open Kansas fields, it looked almost charming from the air. On the ground, it was a killing box. Tanks that had trained for the open plains of France found themselves trapped in what amounted to a maze of natural bunkers. Every hedgerow was a potential ambush point. German defenders, who knew this terrain intimately, would dig in machine gun nests and anti-tank guns at the corners of these fields, knowing exactly where an American tank would have to expose itself to get through. And here was the fatal problem. Sherman tanks could not simply drive through the hedges. When they tried to climb the earthen banks to crash over the top, the tank's thin belly armor, never designed to face upward, was exposed directly to enemy fire for those agonizing seconds. Worse, the climbing tank would tip its nose skyward, rendering its main gun useless, unable to fire back. It was, in the words of the men who lived through it, like fighting blind with one hand tied behind your back. Casualties mounted fast. Some units lost tank after tank trying to punch through field after field, gaining only a few hundred yards a day in what should have been a rapid breakout. Engineers tried explosives to blow gaps in the hedgerows, but that took time, alerted the enemy to exactly where you intended to attack, and used up scarce demolition charges. Some crews tried simply ramming through at speed, only to get stuck, treads spinning uselessly in the dense root systems, engines screaming while German gunners took their time finding the range. Command back at headquarters hadn't planned for this. Pre-invasion intelligence had noted the hedgerows, but nobody had truly grasped how they would neutralize American armor's greatest advantages: speed and firepower. Someone needed to solve this problem, and fast, because every day spent stuck in the bocage was a day the Germans used to reinforce their lines further inland. The man who would crack this problem wasn't a general, an engineer, or even an officer with a fancy technical background. He was Sergeant Curtis Culin, Jr., a member of the 102nd Cavalry Reconnaissance Squadron, part of the 2nd Armored Division, the famous Hell on Wheels. Culin was, by most accounts, an ordinary American soldier. Practical, a little stubborn, the kind of man who fixed things because they were broken, not because someone told him to. He'd grown up around machines and had the tinkerer's instinct that so many soldiers from small-town America carried into the war, an ability to look at a problem and think in terms of what was lying around that might fix it, rather than what the manual said should be done. What set Culin apart wasn't formal training. It was that he had actually watched the Hedgerow problem up close, day after day, and refused to accept it as unsolvable. He'd seen crews die trying to climb over the banks. He'd seen the frustration of officers who had no answer to give their men except try again. And crucially, he was close enough to the front-line reality, not sitting in a planning office in England, to notice something almost everyone else had overlooked. The Germans themselves had inadvertently created a solution. Scattered across the Normandy beaches and the fields beyond were thousands of steel obstacles the Germans had installed to block Allied landing craft and vehicles, hedgerow-cutting devices, beach obstacles, scrapped angle iron, and the remnants of Czech hedgehogs and other anti-invasion barriers. To Culin, these piles of twisted, discarded steel weren't junk. They were raw material. Before Cullen's breakthrough, the situation had grown genuinely desperate. Entire operations were being planned around the assumption that armor simply could not effectively support infantry in the bocage, meaning foot soldiers would have to clear hedgerow country practically alone, exposed to German machine guns and mortars with none of the protection tanks were supposed to provide. Some units improvised their own half-measures. Soldiers piled sandbags on tank fronts, hoping for extra protection climbing the banks. It barely helped and added useless weight. Others tried the cornerback method, sending tanks around the edges of fields instead of through them, but this only funneled American armor into predictable routes that German gunners quickly learned to cover. Reports from the front were grim. Entire platoons of Shermans immobilized in a single afternoon, infantry advances measured in mere yards, and morale suffering as men began to believe the terrain itself might stop the invasion cold. There are accounts from those weeks of tank crews refusing to lead advances into unfamiliar fields, not out of cowardice, but because the odds had become so lopsided. Commanders were under enormous pressure from above. The entire strategic timetable for breaking out of Normandy depended on mobility, and the bocage was grinding that mobility to dust. It was in this atmosphere of mounting frustration, dead crews, and dwindling patience that Cullen's idea began to take shape, not as a flash of genius in a quiet moment, but as the product of watching one failure too many and deciding that somebody had to try something different, rules or no rules. According to accounts from his unit, the idea reportedly came out of an offhand conversation. A soldier joked that what they needed was something like a can opener for hedges, or perhaps forks to lift them out of the way, and Culin seized on the idea rather than dismissing it. He gathered scrap metal salvaged from the wreckage of German beach obstacles, those steel rails and girders the Germans had planted to stop Allied landing craft, and began welding them into a crude apparatus, a row of sharpened steel prongs, or tusks, mounted low on the front of a Sherman tank. The design was almost embarrassingly simple. Instead of trying to climb up and over the hedgerow, exposing the tank's vulnerable belly, the prongs would dig directly into the base of the earthen bank and rip through it, tearing the hedge and soil apart while the tank stayed level, hull down, with its gun still able to fire. It sounds almost too simple to matter, but the physics were exactly right. Rather than fighting gravity and armor design by climbing, the tank simply used raw horsepower to plow straight through the obstacle at ground level, like a hot knife dragged through the base of a wall rather than trying to leap over it. The device became known informally as the Rhino, and the modified tanks earned the nickname Rhino tanks, their prongs jutting forward like the horn of the animal they were named for. What made this genuinely risky wasn't just the mechanical uncertainty of whether the design would even work under combat stress. It was that Culin had built and mounted this device without going through the normal channels of army procurement and testing. Modifying government property, especially combat vehicles, without authorization was not a small matter in a rigid military hierarchy. If it failed, or worse, if it caused casualties through some unforeseen flaw, Culin could have faced serious disciplinary consequences. There was also plenty of skepticism from officers used to relying on standard doctrine and equipment. some of whom doubted that scrap metal welded together by an enlisted man could outperform anything the Army's own engineers had produced. But desperation has a way of opening doors that bureaucracy usually keeps shut. Word of Culin's device reached higher up the chain faster than anyone expected, largely because units were desperate enough to try almost anything. General Omar Bradley, commanding the First Army and acutely aware of how badly the Hedgerow stalemate was damaging the broader campaign, reportedly witnessed a demonstration of the prototype and was impressed enough to order it produced on a mass scale and quickly. This is where the story shifts from one man's improvisation to a full military logistics operation. Rather than waiting for new equipment to be shipped from the United States, which could have taken weeks the campaign didn't have, Army maintenance units across Normandy began scavenging the very same German beach obstacles that had inspired Culin's design in the first place, cutting them into prongs and welding them onto tanks in makeshift field workshops. In an astonishing display of improvisation at scale, it's estimated that several hundred Sherman tanks were fitted with Rhino devices in a matter of days, using material that had originally been placed on the beaches to kill American soldiers, now turned into the tool that would help them break out. Early tests were tense. Crews had every reason to be doubtful. This was scrap metal, welded in the field, about to be driven at speed into obstacles that had stopped tanks for weeks. But when the modified Shermans hit the hedgerows, they worked. The prongs bit into the earthen banks, ripped through roots and soil, and the tanks came through level and firing, instead of rearing up helpless. Commanders who had watched crew after crew die trying to climb these barriers now watched tanks simply tear through them as if the hedges weren't there at all. The payoff came fast, and it came hard. Operation Cobra, launched in late July 1944, became the breakout the Allies had been waiting for since the beaches, and Rhino-fitted tanks played a critical role in making that breakout possible. Where previously a single hedgerow field might take hours or an entire day to clear, with heavy casualties, Rhino tanks could punch through obstacle after obstacle, opening multiple routes of advance simultaneously and denying German defenders the predictable choke points they had relied on. Tanks no longer needed to expose their bellies climbing over banks, meaning German anti-tank guns lost much of the advantage the terrain had given them. Individual accounts from the campaign describe tank platoons using Rhino devices to smash through hedgerow after hedgerow in rapid succession, catching German defenders off guard as American armor appeared where it had no business being able to reach so quickly. While exact confirmed tallies of enemy vehicles or positions destroyed directly because of the Rhino modification are difficult to isolate from the broader chaos of Operation Cobra, historians generally treat any single number attributed to one device with some caution. What is well documented is that the breakout succeeded where previous operations had stalled, and that the mobility Rhino tanks restored to American armor was repeatedly credited by commanders as a turning point in ending the hedgerow stalemate. Entire German defensive lines that had been built around the assumption that tanks couldn't move through the bocage without exposing themselves were suddenly obsolete within days. The psychological impact mattered almost as much as the tactical one. German troops who had grown confident defending hedgerow country now faced an enemy that could appear from directions they hadn't prepared for, at a pace they couldn't match. In the aftermath, the Rhino device spread rapidly across nearly every American armored unit fighting in Normandy, becoming one of the most widely adopted field-improvised modifications of the entire war. It stands today as a textbook example of bottom-up innovation succeeding where top-down planning had failed, a reminder that some of the most important adaptations in military history came not from research laboratories or general staff meetings, but from soldiers on the ground who refused to accept that a problem was unsolvable. Curtis Culin himself continued serving with his unit through the campaign, though he was later wounded in combat. His name is remembered in military histories of the Normandy campaign as the man behind the Rhino, and the device is frequently cited in accounts of Operation Cobra as one of the small, unglamorous innovations that made a massive strategic difference. It's a story that rarely gets the same attention as the beach landings or the big generals, but without solutions like Culin's, the breakout from Normandy could have taken far longer, at far greater cost in American lives. What Curtis Culin's story really tells us is something bigger than one tank or one battle. It's a reminder that history is rarely changed only by the grand strategies drawn up in war rooms. Sometimes it's changed by a sergeant with a welding torch, a pile of scrap metal, and the stubbornness to try something nobody had approved. Ingenuity, courage, and the willingness to break the rules when the rules were getting men killed. That's a thread running through so much of the story of World War II, and it's one worth remembering. If you enjoyed this, like and subscribe this channel for more WW2 secrets.